Hey, today we're going to go ahead and continue talking about solving equations. Now, I first want to go over with you something I've mentioned before in class, and that is the fundamental theorem of algebra. When we were studying quadratic equations, which have a degree of 2, I said we should be getting 2 answers, and that comes from the fundamental theorem of algebra. You see, the fundamental theorem of algebra says a polynomial equation of degree n can have at most n distinct real roots. That means it can have that many answers or solutions. So, if it has a degree of 2, we'll expect to get 2 real solutions. They can be square roots, they could be imaginary, or they could just be a regular, constant, ordinary looking number. Today we're going to be using polynomial equations that have even a higher degree exponent though. Now let's take a look at the method. The first method we'll cover is factoring. To use the factoring method, you need to move all terms to one side and get it equal to 0. So I'm going to move that 12x squared over and rewrite this as 4x to the 4th minus 12x squared equals 0. So I have a binomial. I notice that this binomial has a greatest common factor, GCF, of 4x squared. So I'm going to go ahead and put 4x squared in the front, and I'm going to factor out. Remember, factoring is like dividing by the GCF. So it's like I'm dividing by 4x squared. So 4 divided by 4, and if I take 2 of those exponents away, that leaves x squared. 12 divided by 4, that's actually going to be a -3, and that's what I'm looking at. Now with the factor method, I take each factor after it's done, and I will set it equal to 0 and solve. So I will divide by 4, and that gives me x squared equals 0. Take the square root of both sides, and x equals plus or minus 0. Now that doesn't make sense because 0 has no sign, so we just say the answer is 0. Then I will go back and take the other factor, x squared minus 3 equals 0. Move the 3 over, get x squared equals positive 3, and take the square root of both sides. So I have x equals plus or minus square root of 3. Now that does represent 2 answers. So we say the answers would be plus minus square root 3 and 0. However, the fundamental theorem of algebra said that the degree, which in this case is 4, told us how many answers. Well, I only see 3 answers. If you have MyLab's homework to type in, you would type in the 0 and the square root of 3 and the negative square root of 3. That's only 3 answers. Did you notice back over here I had disregarded the plus minus with the 0? That is called multiplicity. Multiplicity stands for how many times a number is used theoretically as an answer. So for big hardcore mathematicians, they would say 0 would have been used twice. So it's like saying your answers would have been 0, 0, square root 3, negative square root 3. For our purposes, you do not have to write 0 twice. Now let's go ahead and look at another example with factoring. For this one, I need to move all of my terms over to the same side. So I have 2x to the 3rd plus 3x squared minus 8x minus 12. Since it's 4 terms, I will use the grouping method. If you recall, you just draw a line down the middle and take the GCF in the front and the back. So the GCF in the front would be x squared. So it's like I'm going to be dividing both front 2 terms by x squared. So that would leave me 2x plus 3. I will bring down the subtraction sign from the middle. And if I look at my last 2 terms, the GCF is the number 4. So I will put a 4 there. Now, since it had a subtraction in the middle, I'm really going to be dividing by a -4, or factoring out a -4. So that's going to be positive 2x and positive 3. That's good. With the grouping method, the parentheses should match. I have 2x plus 3, and then I have x squared minus 4 as my factors. Now, as you recall, you take each factor and you solve. First, I'll take the 2x plus 3 and put it equal to 0. I move the 3 over, it becomes a -3. I divide by 2, x is equal to the fraction -3/2. That's one answer. Now I'll take my second factor. X squared minus 4 equals 0. I'll move over the 4, it becomes positive. Then I will take the square root of both sides and I get x equals plus minus 2. That represents positive and -2. So indeed here the fundamental theorem is pretty obvious. I have three answers, -3/2, +2, and -2. Those three answers do definitely correspond to the highest degree of 3. One more example on factor method. In this one, it's a trinomial, type 1. With a type 1 trinomial, I can put my two parentheses, and I will notice that it has x to the 4th instead of x squared. Well, instead of x times x to give us x squared, we will simply put x squared and x squared, which gives us x to the 4th. The last sign is a positive, so that means use the same signs as the middle term. So same two signs and they would be negative. What factors of 6, 1 and 6, or 2 and 3, remember they're all negatives, which pair of factors would add to give me the -5 in the middle? You're right. -2 and -3 add up to be the middle term, -5. Now take each factor and solve. X squared minus 2 equals 0. Move over that 2. Becomes positive, and take the square root of both sides, and you get plus minus square root 2. Don't forget to put that plus minus anytime you use a square root to solve. Take your second factor, put it equal to 0, move over that 3, and it becomes a positive 3. Take the square root of both sides, and that would be plus minus square root 3. How many answers? We should expect that we could have up to 4. Right here, positive and -2, positive and -3. We did have 4 answers. Another interesting type of solving equation is not one that's a polynomial. It is a different type. It is a type of equation that has a fraction as an exponent. Now you need to recall that I normally use the TI-30X2S calculator in my classes, and on my calculator, which is a regular scientific calculator, the exponent key looks like this. It has that little symbol on it. Some of you may actually have an exponent key that looks like this, or even y to the x like that. Now, you may have to use that in this particular section. To solve an equation with a fraction or rational exponent, you will take the reciprocal of the fraction. So flip the fraction and use it as an exponent. So I'll put 4 over 1 and 4 over 1. When you do that, the 4's cancel, the 1's cancel, and I'm left with x equals 5 to the 4th power, because 4 over 1 is just 4. You could put that in your calculator and quickly see that the solution here is 625. Now here is another example. To use this one, I'm also going to remind you what the fraction key on my calculator looks like. My fraction key looks like this. It has an A and then a B/C beside it. Now your fraction key may look a little bit different depending on the brand and model of calculator. But we'll work this the same way. You flip the fraction to solve. So I flip over, and that becomes 2 over 3, and then this is 2 over 3. The 2's cancel, the 3's cancel. It's x equals 343 to the 2/3 exponent. Now you can put that directly into your calculator, and I would type it just as I have it written here by hand. Okay, now what you may do on some models though, you may have to put a parentheses around the 2/3 just to make sure that it understands what you're talking about. And when you do that, you should get the answer of 49. Now some of you may prefer just to break this down and work it by hand. This particular number, the bottom number tells you that you're taking the cube root of 343, and then you would square it. Well, the cube root of 343 is 7, and 7 squared does indeed give us the answer of 49. Our last example problem, I'm going to go ahead and flip the fraction, and that will give me 3 over 2, 3 over 2. It's kind of messy, sorry. The fractions on the left will cancel. Excuse me. There we go. And they cancel, and that leaves x minus 2. And then I have 4, and again I'm going to put 3 over 2 in parentheses. Now you can put this in your calculator to simplify, or again you can think of that as the square root of 4 cubed, which is 2 cubed or 8. Now here's an interesting note. Make sure you write it down in your notes. When you flip a fraction and you get an even denominator, you see how the bottom of that fraction is even after I flip it? Then that means you must use plus minus, because basically that 2 in the bottom denominator implies that we're working a square root radical problem. And if you recall the square root method, that always gave us the plus minus answer. So here's what it's going to look like. X minus 2 equals plus or minus 8. I would separate that and solve x minus 2 equals positive 8. And then x minus 2 equals negative 8. I'm going to solve it. If I move that 2 over, it would be a positive 2, and 8 plus 2 is going to be 10. That's one answer. If I move that 2 over again, negative 8 plus 2, remember it becomes positive, changes sign, and that's a negative 6. Final answer. Good luck, everybody.